video, I will be introducing a shorter method for calculating the distance covered in nth time, and this topic is taken from uniformly accelerated motion. So for this very video, we'll be using a shorter formula to calculate distance covered in nth time. So without wasting time, let's read the question together. The question reads, a body accelerates uniformly from rest. Now uniformly from rest means that the initial velocity symbolized by u is what? Equals to 0. That is what uniformly from rest means. Now they said with acceleration of 4 meters per second squared. Now we're given an acceleration in this question, okay? We're told that the acceleration for this question is a equals what? 4 meters per second squared. Now that is not all. What was the question saying? They said calculate the distance covered in the 5th second of the motion. So in this very question, we're asked to find distance covered in the 5th second. Mind you, this question was taken from distance covered in nth time. And the nth time we're given here was what? 5th. So we can say n in this very case is equals to 5. Okay? N here stands for the second we were asked to find its what? Distance. So n in this case is equals to 5. Now prior to now, there was a different formula we used to calculate distance covered in nth time. What was that formula? X nth, standing for the distance covered in the nth time, is equals to 1 over 2a in bracket t subscript n squared minus t subscript n minus 1 squared. Now this was the formula we're using, where if n is equals to 5, this other one will be 4. If n is equals to 3, this other one will be what? 2. So you'll be having something like 5 raised to the power 2 minus 4 raised to the power 2. So perhaps you still don't understand how to work with this formula. We'll be using a shorter formula for the purpose of this very video. And what is that formula? To get the distance covered in nth time, the formula is simply 1 all over 2a in bracket 2n minus 1. And I suppose this is much more shorter than the previous one above. Now, how do we now use this formula to get the distance that was covered in the 5th second for this very motion? Now, if you observe, we're given an acceleration to be 4 meters per second squared. And we're told that the nth second in this case is what? 5th. That is, n is equals to 5. If it was 4th, n will be equals to what? 4. So let's simply impute this into this and get our answer straight. We'll now say x. Now, in this case, we're asked to find in the 5th second. So it will be x5 equals to, if it was 4th second, it will be x subscript 4. That is how it works. It will be equals to what? 1 all over 2 times, what is our a? Our a was given to be 4 meters per second squared. So we'll say times 4 times in bracket 2 times, now what is our n? Our n is what? 5. Good. So these two will be times separately. Then minus, what this should minus from it? 1. So we are progressing. Let's see how we progress from here. It will now be equals to 1 over 2 times 4 times, now watch out. 2 times 5 is 10. Now remove 1 from 10. That will give you what? 9. 9. 2 times 5, 10. Minus 1 from it will give you what? 9. So from here, how do we now solve for that? We'll now say x in the 5th second is equals to, we can say from here, 2 here 1, 2 here 2. So call the survivors out. You have 1 times, this 1 times 2 times what? 9. Now if you do that, 1 times 2 is 2, times 9 will give us what? 18. So the distance that is covered in the 5th second for this very motion is 18 meters. And if you also use this formula, where you say 5 squared minus 4 squared, then you put the value of what? Acceleration, you also get the same answer. But I suppose this one is a much more shorter formula that will help you solve for questions under distance covered in nth time. So I'll be giving you guys a question to try your hands on. Now change this 5th second to 3rd second. Okay? Change it to 3rd second and work out the question using acceleration as 4. Do it to let me know what you think the answer is will be in the comment. Thanks for watching.